Alright, today we're looking at our fifth lesson for exponents, and we're going to look at a zero exponent, which we've already kind of seen, and negative exponents, which we did see just very briefly on the first lesson. So I've got two columns here. So I've got my right-hand side here, and I have my left-hand side. Okay, and it's being divided by our equals sign. So as we have seen before, 2 multiplied by 2 multiplied by 2 multiplied by 2 multiplied by 2 can be rewritten as 2 to the 5th. Now I just want us to start to look down the right-hand side and see that we notice as I'm going from the first one to our second equation, our exponent is decreasing by 1. I might move that over just a little bit. So here you can see we had 5 was the exponent from the first one, and if I take away 1, I get 4, which is my exponent here. If I go from the second equation to the third equation, notice that 4 minus 1 is equal to 3, and our exponent here is 3. If I go to the next one, again, the exponent is decreasing by 1. I started off at 3. If I take away 1, I get a square. And I'm going to do this and look at them all the way down the line. So 2 minus 1 is equal to 1. 1 minus 1 is equal to 0. Okay, so we said we were going to look at zero exponents. So there's one of the first ones that we're going to look at. And I'm going to keep going. So 2, now if I'm getting to the next exponent, 0 minus 1 is equal to negative 1. So we've come to our first negative exponent. I'm going to keep going. So the exponent there was negative 1. I'm going to take away 1. I get negative 2. I'm going to keep going. So I'm going from negative 2. I'm going to subtract 1. I get negative 3. And you can obviously see the pattern. It's just decreasing by 1 the further we go down. And the last one that we'll look at, it does keep going, of course. Negative 4 minus 1 is equal to negative 5. So on our right-hand side, the exponent is just decreasing by 1 each time. On the left-hand side, so the first part of the equation we have here is 2 multiplied by 2 multiplied by 2 multiplied by 2 multiplied by 2. Now, if I want to get from the first one to the second piece, notice that if I divide the first part by 2, okay, I might move this over just a little bit so we have a little bit more room. These will cross out because they become 1, and what we're left with is 2 multiplied by 2 multiplied by 2 multiplied by 2, which in fact is this one. So what did I do? I divided by 2. Okay, if I do that again, so my yellow highlight here, I have 2 multiplied by 2 multiplied by 2 multiplied by 2. Notice that if I divide it by 2, 2 divided by 2 is 1, so I get 2 multiplied by 2 multiplied by 2, and in fact, that is what we have here. So from the yellow one to the green one, again, all I've done was divide by 2. Okay, if I'm trying to get to the next one, again, I'm going to divide by 2, and so 2 multiplied by 2 multiplied by 2 divided by 2, notice that those become 1, and in fact, I am left with 2 multiplied by 2, which is here. Okay, let's do it again. So 2 multiplied by 2 divided by 2, we should expect that we're going to get 2 back. 2 multiplied by 2 divided by 2, this becomes 1, and I get 2 back. Alright, let's keep going. So to get to this one, I'm going to divide by 2 again. I started off with 2, I'm dividing by 2, I get 1, which is what I thought I would get. Now what about the next one? Okay, so I started off with 1, I'm going to divide by 2, and therefore I have a half. Okay, so again, all I did here was I divided by 2. I'm going to do it again. So I've got half. Now I'm going to write it a little different. Divided by 2. Now whenever we have division, remember this is the same thing as 2 over 1, and we're going to take the reciprocal and multiply. So this in fact becomes 1/2 multiplied by 1/2, which is equal to, I'm going to write it, it's a little weird here, 2 multiplied by 2. In an index notation, that is 2 squared. I know all you guys are thinking, you know, why can't you just write it as 1/4? But I want us to kind of use this notation just for this so we can kind of figure out what the negative reciprocal really means. Alright, so if I'm going down here again, I'm just going to divide by 2 again. And we're getting a little messy here, so scroll down a bit. I'm going to use my blue pen here. So right now I've got 1 divided by 2 squared from this piece. Okay, again I'm going to divide by 2 or multiply by 1/2. So just because we're running out of room, I can rewrite this as 1 divided by 2, like that. And again, what is this? Well, it's 1 divided by 2 squared multiplied by 2, which in index notation can be written as 1 divided by 2 cubed. Alright, so notice all that's happening here is our exponent that's in the denominator now is becoming bigger. Okay, so let's try one more just so that we can see. Again, I'm dividing by 2, and so I get 1 divided by 2/3. I'm dividing by 2, or I'm multiplying by 1/2, which can be written as 1 divided by 2 cubed multiplied by 2, which again is 1 divided by 2 to the power of 4, because there's 4 2's being multiplied there. So I get 1 over 2 to the power of 4, and I think we can predict that this one's going to be 1 over 2 to the power of 5. Alright, there was a lot of messiness in there. I'm going to erase a few things just so that we can kind of focus on this side over here. So what I want us to notice is that it's very similar to what we would have done if it was positive. The difference now is instead of having 2 cubed, I have 2 to the negative 3. And that can also be rewritten as 1 divided by 2 cubed. So what did I say there? I've got 1 over 2 cubed is equal to 2 to the negative 3. The yellow piece here, okay, I've got 1 over 2 to the power of 4 is equal to 2 to the negative 4. And if we look at one more, 1 divided by 2 to the power of 5 is equal to 2 to the negative 5. So what I want you to notice is that, in fact, what's happened is I've taken the reciprocal and the exponent has become positive. So all that the negative sign is telling us in the exponent, so our negative exponent, is telling us to take the reciprocal and make the negative exponent positive. Okay, and we're going to do a few examples of that, but I just want you to notice from there. The other thing that's super important that we remember is that anything to the exponent 0, anything, so anything to the exponent 0 is equal to 1. Okay, and I know that we saw this before, but some examples: if I had 2 to the power of 0, we saw that that's 1. X to the power of 0, again, is equal to 1. X multiplied by y all to the 0 is also equal to 1. Anything to the exponent 0 or to the power of 0 is equal to 1. Alright, let's do some examples. And we just answered that question up there. Sorry, I didn't put it in your line. Alright, so it says evaluate, and we have, I'm just going to write it a little bit bigger here, 2 to the negative 2. Okay, remember that 2 can be written as 2 over 1. Okay, so all I'm doing is I'm going to take the reciprocal, and the exponent becomes positive. And remember that from our rules before, this 2 is affecting each piece inside of our bracket, and therefore this is the same thing as 1 squared over 2 squared. We can rewrite this as 1 over 2 squared, because we know that 1 squared is just 1, or we can simplify this to 1 over 4. Alright, another example, a little bit more complicated. Alright, so we're going to take the reciprocal. So the reciprocal of 4/5 will be 5 over 4, and the exponent is becoming positive. And again, this exponent is affecting everything inside of those brackets, and therefore I could write this as 5 squared over 4 squared, which is also equal to 25 over 16. Alright, last example. Maybe I'll go for green here. Okay, so right away, 3 to the power of 0. Anything to the power of 0 is what? It's 1. So we have 2 divided by 1, which we like to simplify, and that's just 2. And we're done.